Section 6.6, Rational Exponents. I talked about this briefly in Section 6.4. D to the 1/5 is the same thing as the fifth root of D. It's the same thing. Now, the numerator goes right here, D to the first, that's the fifth root. So if I had A to the 5/3, this would be the same thing as the cubic root of A to the 5th. What about this one? If I had the 8th root of C, how could I write that? C to the 1/8. Because there's a 1 right there with that C. What about this? X to the negative third, the 4th root of that? That would be x to the negative 3/4. All right. How about this one? If I had to simplify this, well, it would be the negative in front means it's going to be 1 over the fifth root of 3,125. What's the fifth root of 3,125? If you said 5, you are correct. It's 1/5. What about the 8th root of 256 to the 3/8? Well, there's a couple different ways I can write this actually. I could write it 256 cubed to the 8th. But let's be honest, do we want to take 256 times 256 times 256? Get 256 cubed? I don't think so. So I'm going to write this a little bit differently. I'm actually going to change this into the 8th root of 256 cubed. You may be asking yourself, how can I do that? Well, would you agree that 1/8 times 3 is the same thing as 3/8? If you would, then I can rewrite this as 256 to the 1/8 cubed. So 256, what's the 8th root of that? The correct answer is 2. And then I got to take 2 cubed. 2 cubed is just going to be 8. There we go. Now, other things we can do with these. Just because exponents are rational, or fractions, remember rational just means a fraction, that does not prohibit us from doing any other operations. So if I had to take a to the 11/6 times a to the 5/6, well, it'd be the same thing as if I said a to the 11th times a to the 5th, you would say a to the 16th, wouldn't you? Same thing here. I'm just going to add the two fractions. 11/6 and 5/6. If I add those together, it's going to give me 16/6. But I can reduce that fraction, of course. 8/3. Bingo. This one, r to the negative 4/5. Well, we would think it would be 1 over r to the 4/5 because the negative brings it down to the bottom. The problem here, though, is we have to remember that this is the fifth root of r to the 4th, all under 1. Can I have a square root or a fifth root on the bottom? Technically, no, I can't. So I need another r on the bottom. So I'm going to multiply it by the fifth root of r and the fifth root of r. So ultimately, my answer is going to be, add room there, the fifth root of r, that'd be r to the 5th on bottom, the fifth root of r to the 5th, which just becomes Those cancel out, just give me r on bottom. Looking at this one, the fourth root of 32 divided by the third root of 2. Well, let's simplify this, shall we? I can rewrite this as the fourth root of 2 to the fifth power. This is just the cubic root of 2. Which means this becomes 2 to the 5/4 divided by 2 to the 1/3. And if I have 2 to the 5/4 divided by 2 to the 1/3, we know how to simplify that. Just like if I had the problem 2 to the 5th over 2 to the 3rd, I would subtract them and get 2 to the 2nd. It's the same thing here. I have to subtract the exponents. So what is 5/4 minus 1/3? Well, got to get some common denominators. So multiply this by 3 over 3, this by 4 over 4, which is going to give me 15 over 12 minus 4 over 12, which gives me 11/12. 2 to the 11/12. That's the correct answer right there. Next one right here. What if we had the cubic root of 16 x to the 5th? Well, let's change this, shall we? 16 is 2 times 2 times 2 times 2, which is 2 to the 4th. And I've got x to the 5th. Cubic root of this. Well, let's change this up into here into 2 to the 3rd times 2, and then x to the x cubed times x squared. Now the third root, I can rewrite this as 1/3. Now if I distribute this, those cancel out, I just got a 2. Those cancel out, and I just have an x. So I've got 2 to the 1/3 and x to the 2/3. So that's going to get, I can rewrite this as the cubic root of 2 and the cubic root of x squared. But since these are both to the third root, 2x to 2x squared. There we go. We're going to have one more example here in just a moment. Sometimes they'll give us fractions with rational exponents in them. Once again, we remember this is the same thing as the square root of y. Well, we know how to deal with this. Got to multiply by the conjugate. So I'm going to multiply the bottom by the square root of y plus 3. And the top by the square root of y plus 3. And so then we'll distribute. Square root of y times the square root of y is what? The square root of y squared, which is just y. 3 times the square root of y. And then we have another 3 times the square root of y. 3 times 3, of course, would be 9. On the bottom, square root of y times the square root of y is just y. Square root of y times 3 is plus 3 square root of y. Minus 3 square root of y, those cancel out every time. It's amazing. And negative 3 times 3 gives me negative 9. So once I simplify the top here, I'm going to get y plus 6 times the square root of y plus 9 all over y minus 9. Now, you may be saying to yourself, hey, I can cancel out the 9 here and the 9 here. No, you cannot. Don't you dare. Or you may be thinking, oh, hey, I can cancel out the y here and y here. Don't you dare do that. Why not? Here's why. What if I said 2 plus 3 divided by 2 plus 100? We would know this is 5 over 102. According to you, though, if I can cancel that out, it's going to be 3 over 100. Or maybe like, no, Mr. Kuhne, those are 1s. Okay, fine. You think that's better? It's 4 over 101. Is that the same as 5 over 102? No, that is wrong. Don't you dare cancel those out. If they're added or subtracted, you cannot use them to cancel out. Only things that are multiplied together. If it were 2 times 3 over 2 times 100, can I cancel out the 2's? Yes, I can, because those are being multiplied. But can I do it if I'm adding them together? Clearly not. Clearly not. So, this is our final answer here. Nothing more to simplify. I can't simplify. Cancel out the y's. I can't cancel out the 9's. Nothing else. Stop right there. Thanks for watching.